Good afternoon. Thank you for coming and joining us. This is the Using Docker track. We've got a fantastic session coming up with Scott Coulton. He's a senior engineer at Puppet. You're a principal software engineer, excuse me. He's also a Docker captain, which means he is in that very small elite group of Docker experts, and we're delighted to have him here. Scott's going to talk about Kubernetes, running Kubernetes in production with a special focus on security. So this is going to be fantastic. And a big hand, please, for Scott.
Thank you. Hey, how's it going, everyone? Thanks for coming out to this talk. First, I'll start a little bit about me. As you can tell from the accent, I'm from Sydney, Australia. I'm in the Docker Captains project. I work full-time at Puppet. I head up the cloud-native engineering efforts at Puppet, and I've got a few different teams working with me, and do mostly stuff in the development space, mostly in Golang. That's my day-to-day job, and also around containers. For probably the last year, I've been just 100% focused on Kubernetes or the Kubernetes ecosystem. I'm just going to go through some of the best practices that I found running Kubernetes in a production environment and some things that you can get yourself into trouble with. Also, there was a really relevant news story today that broke about a Docker Hub image that 5 million people downloaded that was a crypto miner. And then there was an exploit in it that allowed it to respawn itself. So I'm actually going to use that as an example of like what not to do and how to protect yourself from it. It literally came out at 10 o'clock this morning, and I added it to the talk. So the talk's like super relevant. So first of all, we're going to build a CAS. I actually cached this because Adrian in the talk before me was having some issues with the wireless. So I actually cached some of this stuff. I was going to build it live, but I've cached some just in case the wireless didn't work for me. We're going to have a look at what's different between Swarm and Kubernetes in the EE platform, and why you would choose one or the other. And then we'll get into a whole heap of SecOps stuff and really have some fun. You'll notice throughout the talk I have some really bad GIFs. Security talks are usually really, really dry, so I thought I'd add a bit of humor to it. So we'll build the CAS first. I've actually cased this, as I said. So imagine I'm a developer or an ops person, and I'll put my security hat on. This is what I see. I can see that we've got some cool stuff in EE. I can see that we've got Kubernetes, we've got Swarm, we've got some stuff here that say, hey, there's a content trust, I can learn more about it. But how do I know that that's all configured and what's happening? So I'm assuming that this has been rolled out in a production environment using your configuration management tool of choice or something like that. I'm going to obviously be biased and say Puppet, but I'll give our vendors a shout out, could be one of them as well. This is not a vendor pitch. But Puppet does pay my bill, so we'll say it's Puppet. And this is in a production environment now, and you want to make sure from your SecOps hat that Kubernetes is running securely. And out of the box, there's some stuff that EE will do for you that's already enabled. So like, for example, all the communications for Kubernetes are TLS encrypted out of the box with EE. So I don't have to worry about certificates. Other things around the Raft consensus are looked after for me, and etcd, so I can take that out of the equation, that I don't need to look at that with my security hat on. This is going to be like an entry-level sort of talk. If you want to learn more about like zero trust microservices and stuff like that, come and talk to me afterwards. I wasn't quite sure the depth that I should go down in security, so this is going to be fairly 101. But if you want to get into a proper like deep dive into microarchitecture security, come and grab me afterwards. Just out of a question, how many people here are security people? Oh, awesome. Do you know I said that at DockerCon last year and there was 2, so that's good. Security should be part of like the application workflow from the beginning. How many people are ops people? Okay, we got heaps of ops people. Developers? Okay, cool. More developers than anyone else. That's cool. So yeah, if I put my security hat on and I'm like, I've got this dashboard and stuff, I can say, cool. It looks like there's some security stuff there, but how do I know, and what do I need to look for to make sure that my like CAS environment is actually locked down? Oh, I actually forgot to do another awesome slide of a live demo time, which I just did. So if you're a security person, do you know what the architecture of Kubernetes looks like? Or are you like John Travolta going, huh? What's going on? So from the people that I've talked to in the security landscape, this is usually very foreign to them, and how to lock this down is not quite as straightforward as they would be used to. And using security with Kubernetes, you actually are able to do security controls at the front of the application lifecycle instead of the end of the application lifecycle. What I mean by that, to elaborate, is that in Kubernetes, you can deploy a pod on something that is replicated as production, or even in the build process that starts doing image scanning, vulnerability scanning, and crypto signing before it even hits a production server. Now, if you look and go back before containers, you had to deploy something to a production-like environment, then run Tenable and do a whole heap of stuff there. Possibly you were just still doing that in the production environment. With Kubernetes, you can move that all forward, and you can actually stop vulnerabilities getting out there and patching them before they get there and remediate them, then doing it like on a live box. So that's super powerful. So we'll have a look at some of those sort of stuff. So this is the platform architecture, and like this really shows you what's running at what part. And you can see platform security there is a box that goes over most of it. And we'll talk about that in a lot more detail, obviously. But it allows you to have like the same security platform across like cloud, virtualization, and physical. And EE does have a lot of bells and whistles in it that a lot of people don't turn on. In a previous life, we actually built a Notary plugin for Jenkins when Notary was like way before it was in CNCF, actually before it was in UCP. And it was super difficult, but we wanted to have crypto signing on our images. So now all this has been abstracted, and there's like a product that just allows you to click a button and do a few config files in JSON, and then away you go. So we'll talk about it. But you can see there that like, the platform architecture pretty much covers everything, and everything in the Docker Enterprise solution has this platform security on top of it. So it allows you to have a lot of control, or fine-grained control over what's happening on the platform. Here's the Docker EE architecture. As you can see, you can have Windows nodes, you can have Linux nodes, you can have Swarm, you can have Kubernetes, and you got your node managers there. The one good thing that is implemented in Docker EE is the least privileged trust system. So that means that a manager can only do all the executable tasks, or any of the cluster configuration tasks, or any of the what would be classed as tasks that are administrative. And workers have no privilege to do anything, which is what you want to start off with. So as you can see here, there's a few different app scheduler methods. So you can see Swarm or Kubernetes. You can see that there's got the secure cluster management. What we're going to do is boil right down into that box right there, what the secure cluster management is, and really look at how we can secure it. But first, what's the difference between Swarm and Kubernetes in the EE sense? Now, there's a disclaimer here that this is not Kubernetes upstream. This is like in the EE context. So you'll see why. So with Swarm, if you choose to use Swarm, the Raft consensus is encrypted by default inside Swarm. You don't have to worry about the Raft algorithm. It's all done for you. Snapshots of the Raft consensus, the Raft database is also done. Applications are deployed by stacks. Of course, you use the Docker CLI, and you only have the choice of overlay networking. That's the only choice you have. If you go to Kubernetes, then obviously you use kubectl. I know there's a massive talk about what that's called, and Adrian said this before. I've got the microphone, so it's kubectl. It could be kubectl or whatever you want. There's a whole lot more of fine-grained deployment mechanisms. So there's pods, there's services, there's deployments, there's ingress controllers. There's a whole heap of stuff that you can do. Swarm doesn't really have that sort of granular control. And also, even on EE, there's the CNI network functionality, so you can plug and play any networking provider you want. It ships out of the box with Calico, so you can do some fine-grained controls around that. But if you wanted to use something else, if you go to the docs on UCP, it supports Weave, Flannel, all the major ones that you would find the Kubernetes supports. The thing in Docker EE, and this is super important, is you can swap and change as you will. So you can actually use a node as Swarm and then swap it over to a Kubernetes node. You can do vice versa. And both of the commands work. I just wanted to show that because we heard a little bit about it. So I've already got it here, Docker node ls. And you can see I've got my 3 machines. And if I go kubectl get nodes, I've got the same machines. So if you are looking at migrating from Docker to Kubernetes and you want like a stopgap of like how to work out things and how to get there, this is super powerful. You can also deploy Docker Compose files. There's a service inside EE that will compose to CRDs for Kubernetes and then deploy them. So again, that is super powerful because the learning curve on Kubernetes can be a lot more than it is on Docker itself. The other good thing is that you've got Docker Engine installed here. So out of the box, there's some security stuff that you don't get out of the box if you run, say, Containerd. Containerd, you can do it. Don't get me wrong. It's not that it's not in Containerd. It's just that you have to plug in Uparmored yourself and the profiles and a whole heap of stuff. So live demo, I just missed the slide again. That's good. Twice in a row. OK, now we're going to get to the fun stuff. We're going to get to some SecOps stuff. So we're going to have a look at a real-life attack. And this is the one I spoke about yesterday. So what actually happened is hackers going to hack, right? Docker's become heaps popular. And there has been an image that's on Docker Hub from a person, and it's called, the author was Doc My Life, and it was a memory testing application. It had over 5 million downloads, which I'm sure that they wrote a bot and just started to get downloads up, which is super easy to do if you just have a couple of different IP addresses and not like hitting it all from the same and just rotating those around. And if I was a developer and I have a look at Docker Hub, the first thing I look at is how many people have downloaded it. And then I have a look and see if there's stars. And then after that, you don't really question much more about where it come from, maybe if it was from library. And then there was the first warning sign was there was no Docker file with this. So if you're going to pull something from Docker Hub, probably the first thing that you want to do is make sure there's a Docker file, because you can see what the binaries are actually doing. Researchers actually had to do inspect the container and find out what this was doing to find out that there was what it was actually doing. So even if you use vulnerability scanning, it wouldn't have found it because it's actually the binary that you were injecting was vulnerable. So if you have it here, this is the first issue launched on GitHub about it, and it was a while back actually. Have a look. It's in 2017, so this has been running for a long time. And if you have a look there, they deployed it, and they accidentally left the exposed Docker API port open, and this reported back that that was open, and then they started hitting it and spawning up more stuff on their host. So even when they tried to stop the container, it was respawning itself, and they had to restart the daemon and change their firewall rules. So this is a fairly easy mistake, right? So maybe someone was trying to debug some sort of panic error in Go, wanted to see a breakpoint and then use this application called memory test or something to see where something was. Like a developer just sees it and goes, hey, this has been downloaded 5 million times, how bad can it be? And it's on Docker Hub, we'll just run it, and then boom, this has happened. And as I said, this image has been up there since then, so the research only got released this morning. It's been pulled down off Docker Hub now, but that's how many months since August 2017. And if you have a look at this, this issue, there's tons and tons of people reporting the same thing. So how do we protect ourselves against that? Do we just put a few pillows around our devs and go for it, and then try to whack them when they do something bad? No, that's a horrible idea. So in Docker, there's a secure supply chain, and this is super important. There's no one fix actually to prevent this issue. It's a multiple things that you need to do to make sure that you're secure. And in fact, I'm going to get into some Kubernetes native stuff later, but this is Docker EE stuff. This is also open source. You can bolt this together itself if you want. Except for the image scanner, the Docker one's not open source, but there is other ones you can find. Basically, what you want to do is, when someone builds an image, you want to make sure there's no vulnerabilities in it at least. So what you need to do is have some sort of CD process. Your developer pushes the image. It runs in the build system. It looks at all the file image layers and sees if there's any vulnerabilities. If you have a look at CentOS right now, there's a ton of high vulnerabilities that are not being fixed in the container right now. go to Docker Hub. You can click on the link, check out the builds, and have a look. Or go down and speak to the people at Aquasec. They'll show you a live demo of their new open source tool, and you'll see CentOS has actually got 3 vulnerabilities in it that are critical. And there's no patch for it in the container at the moment. So if you're an application developer, and I put my security hat on again, if I'm a security person and my application developers are saying, like, I just need to get CentOS, that's like the base image we use for our machines, maybe on your cloud provider or on-prem. And you've got a mature patching process for those. Does that mean that the CentOS you would assume would be the same from Docker Hub? Not necessarily. But it would be easy for the developer to go, well, but I'm just using CentOS 7 and we use CentOS 7. What's the difference? And without doing the checks and balances about what actually is coming from that particular image, how do you know that you're not shipping something with like a 0-day, or not a 0-day, but a critical vulnerability that there's a Metasploit payload already for? So like some teenager that's 13 can already exploit you because like it's freely available on the internet. That's where you need to have your checks and balances, because like the turnaround from like vulnerabilities being found to Metasploit actual like scripts being out there is like ridiculously fast. It's like sometimes 27 hours or less. And then that can be shipped to anyone that runs Metasploit that's open source, right? So before you know it, there's like a whole heap of kids in the basement like that were playing Call of Duty that said, hey, there's a new Metasploit, let's just like kick that off. And that's literally how easy it is. And without patching, and like we shouldn't be patching containers, so you have to have a whole redeployment mechanism and things like that. But yeah, back to it is like you push the image to DTR. DTR will have scanning. You can check how often you want it scanned. Like a good sort of time would be 12 hours. And if something becomes red or it finds that there's a vulnerability, you can actually block that image from being pulled. And that's super powerful. That doesn't fix that if you've already got that image in running. And one thing to never do, never ever run latest tag. Because if you've got latest in your, and you've got a vulnerability there, is that the latest that's on the machine? Or is that the latest that you built today? Or is that the latest when? Make sure that when you're doing this and you want to do it securely, you're tagging with a semantic versioning or a git commit hash. Because yeah, if you're just using latest and then you do an audit about what containers are out there and they come back saying, oh, we've got latest of everything, and someone else has done another build, that latest that's running there might be from yesterday, and then the latest that you've got in DTR today is being built today. They're not the same. They could have different file level cached images and a whole heap of different stuff in it. So this is why this is super important. To first of all catch stuff that's upstream. There was a really interesting metric talked about it in KubeCon. If you run Kubernetes, and just before you get to your application, there's over 10 million lines of code if you're running it on a Linux machine. So that's 10 million lines of code that anything could be vulnerable in that whole stack before we even get to yours. And that's amazing. I thought that metric was amazing. Obviously, there's like trust systems around OSs, and Kubernetes itself has some testing and things like that. But think about all that code that you have. You can only actually control like the most minuscule bit, but the attack vector is actually higher on your little bit of code than it is for everything underneath it, because chances are that you're the one exposing to the outside world. So you want to really be doing checks and balances, making sure you're not shipping anything that's vulnerable from day one. So here it is again. This is really what you want to be doing. So you got Docker for Mac, or if you're on Linux, there's no Docker for Linux yet, but I keep hearing it's coming. But you can just run native Docker. That should be fine if you're using Linux. So you should have a test environment where your devs can test. That's your integrations, things, and a whole heap of stuff like that. And then you should have automated policies about like what can be used, how it gets signed, and if it's vulnerable or not. Then it can get pushed to the other stages. This is super important as well. There's another really good thing you can do if you really want to be thinking with your security hat on, is that there should be somewhere in your maybe your operations team or your dev team, that you should have a golden catalog of images that you're base off that are signed with your crypto signature. So like even if you've got like your base from Alpine, get Alpine 1.7, fork the Docker file, put it on your own source code. Then you can do like from your version of Alpine and crypto sign it. At that point, when you crypto sign it, you know absolutely nothing's changed on it. and then get your developers to put their application on top of it, and then crypto sign that again. So you've got a crypto signature chain that allows an auditor to see the differences as they go through the CD process and get deployed. That's also super important if you've got people that are wanting to do auditing. So if you're in the PCI or any of those sort of things, you can show where it was, when it was signed, what vulnerability scanning went on. Then you added your application on top. It was vulnerability scanned again, and then we signed it again. And then you've got to trust with your engine. If you want to stop actually, this would probably be the best way to stop in a production environment, the developer being able to get that crypto machine on there. They'll still get it on their Docker for Mac, but I suppose the attack vector there is really small. That if you only allow your engine to spawn signed images from your registry, or if you do trust Docker Hub, you can trust upstream. But if you want to be really secure, just from your internal registry. That means if someone gets on a box and they go like kubectl create -f and a file, and inside that Kubernetes file there's some pods and some containers. If that doesn't have your crypto signature on it, once it gets passed down to the runtime, it won't spawn it. It'll pull the image, but it won't spawn it. You'll get an error. And that becomes super important. Going back to the policy, if you've got a vulnerable image and someone says, oh, like, for example, I don't know, they can't get the latest version of something working on a package that needs to be patched. So they try to run in CD and install the old version that's got a vulnerability in it. If you've got the policy set up to allow your engine not to do that, they won't be able to spawn a container from that image, because you would have blacklisted that image. So there's no like backdoor round to say, hey, I'm not going to use the latest one because my application broke because the new version of the package broke something. It's a hard line that security can take to say, no, you have to use the one that's not vulnerable. The engine will only trust this tag of this image. So that's super important as well, and it gives you a really good audit chain all the way through. And that, of course, is the open source framework that it's built on. It's part of CNCF now. So there's going to be a lot more work done on it. The open source one is really tricky to get set up. In Docker, it's like super simple. So we'll run through that. Oh, here we go. Oh, sorry, I've got another diagram that pretty much talks about the same thing. So you can see version control, trusted registry, another trusted registry, and you can see the signing going on multiple times there. So every time you make a change, you should change the tag. Tag should need a new crypto signing. The ops team should not own the whatever you're signing with the certificate authority. That should come from another team, possibly the security team. So you've got separation of concerns. So someone else actually owns the cryptology, the cryptography, and not the ops team, because like if you go back and get audited, then you can fudge it if you hold the keys and the lock at the same time, which is never a good idea. So yeah, my best practice would be to offhand the crypto to the security team or whoever handles auditing, and then just ingest that as a consumer if you run the pipeline that deploys the applications. Then, as I said, when you go through the audit process, it's super easy to say that there's a separation of concern. The person who has the keys can't get to the lock, and vice versa. Because, as I said, if you've got the keys and the lock to an environment, it's really easy to fudge or change. And here's a lot more advanced if you want to take a photo. All my slides will be out after the talk. I'll tweet them out, and then Docker will send you an email with all the slides as well. But as you can see there, you can see it manages the repository. You can see the Docker Compose up. You can see the signature there. You can see the CI agent. So as you can see, all the way through, we're checking signatures. We're making sure that vulnerability scanning is done. And this is not Kubernetes specific, but in EE, this will work on any scheduler. If you want to, as I said, it will work on Kubernetes open source. It will take a bit of work to get working, though. You'll need a fair bit of reading around Notary and possibly hook it into Containerd and cry. But if you want to configure the Notary client for Docker Hub, this is all you need to do. So you need, like with EE, in your home directory of the user that you're running, you just need to trust notary.docker.io. Docker actually has a trust system based up with the engine on anything in library. So there is signatures, and if you have a look at projects like LinuxKit, and you're building an OS that's container-based, everything in LinuxKit from LinuxKit is signed by the Notary Docker.io. So therefore, you've got some sort of trust that if you're using the kernel, that there hasn't been a man in the middle or some sort of weird kernel module being added by a third party, and then you've downloaded it and the base of your Linux kit image is like being attacked. But there's a trust there with the native Docker one. If you want to do yours, there's the same file, and then just add your URL and then your CA that you've been given from someone else. And then you just have to push and sign. So once you do push and sign, you just make sure you export that. If I was doing this in a build system, I would probably have that set up as an alias that the machine already had that step to set Docker trust to 1. Then Docker push, and as you can see, the tag account repository. That crypto signature will then get shipped as metadata within the file system. When it gets pulled from the Docker engine, even if Kubernetes is running on top, it will check the hash. If the hash is not correct or something's been changed, the container won't spawn. If there's a blacklisted policy saying that the tag's not allowed to spin up, container won't spawn. It will still download the image though, but at the moment, that's. If there's one takeaway from this talk you see, that's quote me, sign your images. Like, it's really super important. If you look at the attack that we spoke about today, if you had a zero trust policy from upstream, you forked everything to your own registry that ships with EE, whether you're using Kubernetes or not, you signed your images. When you went through that test phase, before it got to any production environment, you would have caught it. It would not made it anywhere near your production environment. And this is what I'm talking about, whether it be on Kubernetes or whether it be on Swarm. It's super powerful. Everything we spoke about now has been pre-get into the orchestrator. So all the protection mechanisms, everything that we've talked about, we can do before it's even hit a production server or a test server, which is super, super powerful. And if you have a look at the way we were doing it in the security world before, it was always we'll deploy it and then we'll test it when it's in like a staging or UAT-ish environment that could be or could not be kind of light. This allows you to do it all in the CD process and all upstream. So if you're in a security team, I urge you to be inside the process with app developer teams, talking about this stuff and getting them in on as soon as applications get deployed. It makes everyone's life easier. The other thing that I've learned in real life examples, if you try to retrofit this stuff, it is, excuse the French, effing difficult to get in. Because you've got application developers that will say that there's vulnerabilities that's in packages they've already deployed. Crypto signing, there could be some sort of issue with setting up the SSLs. It's super easier to set it up from the beginning. Even if you want to do, if you are doing it afterwards and you've already got a like CAS out there, I would recommend building a new like CAS on the side and then setting up all the security controls and then migrating your workloads across to that. I think you'll have a lot less pain than retrofitting it into an environment that's already running. So now we get to Kubernetes. So now we've got all our controls around what's going to get to Kubernetes and what's not. That doesn't necessarily protect you if, like, say that like there is all that chain could have been broken. Say that the crypto mining app, you didn't have static code analysis, and that binary got through, and you signed it. So human error. It will happen, nothing's 100%. So we'll just put our hat on and imagine that crypto mining image, we've tried to do our best practices. Security vulnerability, like the image that was on looked clean. There was no like package vulnerabilities on it. We did no static code analysis though. So we don't know what the binary is doing or the code running on it's doing. And we've signed it. So our developers think it's good. How do we protect ourselves again on the Kubernetes layer? And I'm just going to go through some stuff that's like built into Kubernetes. This is applicable to EE and open source. It's just a couple of really, really simple best practices that you need to do and will protect you in case something does slip through the nets. And as I said, it's completely possible that it could be missed. And it's just something as silly as like there's no static code analysis done or analysis on a binary inside a container. So if you're missing that step, you could have like signed it, shipped it, people think it's all good and away it goes. The first thing is like don't run as root. This is really simple. It's a security context, and it's as simple as that. What more can I say? If you have a look at what happens if there is an escalation and they try to break out of a container, which it is quite difficult to do. You need the moon and the sun to align and all these things. So then you need a kernel vulnerability. You need a whole heap of stuff. But like Dirty Cow was one that aligned all that. And if you had the full fork kernel, it wasn't patched, you could actually exploit and break out. So run is non-root because that maps the UUID on the underlying host. So if someone breaks out and they're root in the container and they get out, they're root on the box. And then you might as well shut shop because it's game over. They've got full access to everything. Read-only file system. So there's a whole heap of stuff that you can do to make sure that their processes can't run inside stuff that shouldn't. Perfect example of this is I had an Nginx container. I did this talk at Container Camp. I had an Nginx container. I allowed it to only run the log file in var.log and the PID file that Nginx needed to run. I fired up a container, sorry, I did that second. I fired up a container first that had temp enabled. Inside the temp, there was a Dirty Cow binary, and I was able to privilege escalate up. Because like, why would a container need a temp? Shouldn't need a temp file system. So I did, read-only root file system. And with this, I couldn't execute the binary because like it was read-only. So this is really, really simple stuff, but a lot of people don't know about this, and you really, really should be doing it, especially in production. How I would do this is like when hopefully you're not just doing kube control from a desktop into a Kubernetes environment. Hopefully this is like a CD process where the kube control with the certificates and stuff is on an automated system. In that CD process, you could start looking at the YAML files and making sure that they've got these sort of things involved, in them. If they don't, you could break the build and send like a Slack message to the developer and say, hey, your security context is wrong. That's the sort of stuff that I would be looking at doing if I was working on that. And this one is very, very important. In a container, there's very few reasons why you should allow privilege escalation, especially in a production environment. Very few reasons. If you're running as a non-root user, the only a perfect example Adrian gave was even the Redis container. It starts off and chowns some stuff as root and then changes user. But it doesn't escalate privileges. It actually downgrades privileges. There should be no reason in a container that it ever escalates privileges. Never. So set this to false. By default as well, all these things in Kubernetes are set, either not set or set to true. So like this is by default set to true. So any container, whether it be open source or not, and Kubernetes, you can privilege escalate in it if the possibility is there to do so. And you don't have to choose one of these options. You can choose all three. And this will cover you from a lot of different things. Which is, sorry, my thing down there, I've got 6 minutes left. Okay, cool. We'll rush through it a little bit. So this is like super important. As I said, like obviously some things can't run as non-root. If it's something you're building, like a third-party application from from Docker, might need root. So maybe you just want read-only file system and privilege escalation to false, but I don't know. But if it's an app you're building yourself in-house, you should definitely be able to control these things and set all these environment variables inside your pod manifest. And then we get to some tricky bits. By default, if you use Docker as the runtime, SE Linux and Uparmored are turned on by default. How many people knew that? Okay, cool. Only a few. All right, so if you're running Kubernetes on top of it, Kubernetes does not have that turned on by default. If you're running Docker as a runtime, you can set it as on the pod context. If you want a really good blog post on it, Jess Russell, she's super smart, knows a lot more about this stuff, especially on the kernel level than I do. Definitely check out that blog post. It's really good. But simply to add an Uparmored is that annotation inside the metadata to pass up the default Uparmored profile from the engine that ships with Docker that Jess Russell put there many Dockers ago. And that will protect your application with a whole heap of default profiles, and it will also protect the container to be able to mount kernel modules that it doesn't need to at runtime, which is super important as well. And I'm a Debian person, so I use Uparmored, but if you're an SE Linux person, You've got the same ops if you're into Red Hat. There's SecOps as well, but I didn't put it in the slide. But you can definitely use SecOps as well. So these are all base stuff that's built into the engine that you can pass up through Kubernetes that are not turned on by default. This will save you, like, if you followed every step that I talked about today, and even if you deployed that crypto miner, it probably wouldn't be able to run because of the different policies you put, especially like the SecOps one and the Uparmored one, because it was starting to spawn multiple processes, and Uparmored wouldn't have allowed that to do so. And it would have started trying to write a cache somewhere for the mining, and again, Uparmored wouldn't have allowed it to do that. Just to go back one step, you can write your own runtime for Uparmored, but I don't know that many people that enjoy doing that. It is quite an arduous task to write your own Uparmored profile. It's like pretty dry. So 90% of stuff will be covered by the Docker default one. If you've got something that's like custom, you can write your own. You will just try and runtime default to wherever you put it in, like etc Uparmored and whatever it's called. That's it. I think I covered a whole lot of stuff, and I've got 4 minutes of questions. So. Any questions? Well, thank you.
Great stuff, thank you, Scott. If you've got any questions, there's a microphone in the middle there, so come on up and ask. And Scott's around for the rest of the conference, so he would love you to just corner him in the corridor and talk to him for ages.
Yeah.
Thank you very much.
Thank you.